All right, everybody. So we have John from FLO Cycling Wheels on the podcast. And this is a podcast that I have been looking forward to for a long time because it seems at times like it could be such a small thing that people look over in terms of how do you get faster on the bike. And we're going to go into some pretty deep stuff today about wheels, tires, rolling resistance, drag, tons of stuff. And I'm super pumped to talk to you. So thanks for coming on, John. I'm pumped.
Hey, you're welcome, man. Super happy to be here. I love doing podcasts, so
Yeah.
let's do it.
Yeah. And the beauty of this is I think that the first upgraded pair of wheels that I ever purchased were your wheels, and I cannot remember to tell you the date. I mean, it feels like it was over 5, 6 years ago.
Yep.
And the cool thing about your wheels is like I had a white and blue and orange speed concept, and I could get wheels with the decals that, of course, matched it, and it looked sweet. So it's cool to be talking to you.
Thanks, man.
Yeah. So I think, I want to go through like a little bit of rapid fire just so people can get to know you. And some will be really quick questions. Some will be like an overrated, underrated type of format. But let's roll into it. So,
Let's do it.
sporting hero, growing up, or a current sporting hero.
Oh man, that is good. I would say Joe Montana.
Very nice. Very nice. Yeah, football. Overrated, underrated, gator skins.
Oh man, they're overrated in one way, but underrated in another way. It's very fascinating tire.
Cool. Um, Best Twitter follower or like an academic educator type of thing.
Dr. Steven Seiler.
Love it. Totally agree. This is a hard one. Favorite movie?
Man, it always comes down to two. Saving Private Ryan.
Great movie. If you could go back and pick a different career, what would it be?
Ooh, man, I don't know. I would probably change my. I'm a mechanical engineer. I probably would have become a like a computer scientist or a computer engineer.
Cool. Overrated, underrated, 110 psi.
Oh, so overrated.
Overrated, underrated, wide tires for a road
Underrated.
bike. Okay.
Underrated.
Underrated. Overrated, underrated, bike weight.
Oh, totally overrated.
Okay. Overrated, underrated, disc wheels.
Uh, can I go neutral on that? Because I mean,
Sure.
let's go neutral. Let's go neutral.
Okay. All right, we got two more. Um, Overrated, underrated, Continental 5000s.
Oh, underrated.
Cool. All right, last one. This is more of a question, and you do this on your podcast, so that I'm definitely kind of inspired with it. So, with the right wheels, the right tires, how much faster can an athlete go over an Ironman distance with the right wheel and tire setup and tire
Right
pressure?
wheels, right tires, right tire pressure. You could save probably 12 to 13 minutes on an Ironman.
I'm in. Tell me what they are, and I'm gonna use it for Wisconsin. Too good.
Too
Sweet.
good, too good.
All right. So Flow Cycling, and I mean, how did the company start? I mean, what was the year you started? How did the idea come about? Yeah, let's dive into how did this whole thing start? Because it's blown up.
Yeah, man, it was 2009. My brother, twin brother, was a triathlete. We just graduated from university. We had these desk jobs and we were going to the gym a lot. And he was like, hey, I want to do something different. I want to do something that's more challenging again. We skied growing up, raced growing up. So there was some competition there. And he was reading a Men's Health magazine and he saw this thing called triathlon. He's like, "What's that?" He's like, "I can do that." So he's just started piecing things together, and he bought this bike, and it came with like these, or he bought these wheels, these Nugent wheels. What was his name? John Nugent, great guy. He had Nugent Cycling, which is uh, they closed a few years back, but he had these bought these wheels from him. They worked really well, and then all of a sudden he's like, "I want to get some deeper wheels." So he did a lot of research and he ended up buying a set of wheels, brought them home. We were living in the same apartment at the time, and he showed them to me, and I was like, "Oh, those are cool." He goes, "What do you think these cost?" And I was like, "I don't know, $500." And he was like, "No." And I'm like, "What, lower?" And he's like, "No, higher." So he kept going up and up and up, and then he told me he paid like $2,500 for them. I'm like, "Man, you're nuts! You're crazy. That's just crazy." And he goes, "Do you think we could do it more affordably?" And I said, "Yeah." And we both have mechanical engineering backgrounds, degrees, and we're working as mechanical engineers at the time. And he said, "Do you want to start a company?" I go, "Sure, why not? Let's do it." Because we had done some things entrepreneurially before, and always been sort of experimenting with that, and so I think this could be really cool. So that's how it started. Really, is it was a it happened in about 30-second conversation that we decided we were going to start this business, and so we did. I mean, my next question to him was, and I had a bikes growing up. We rode mountain bikes and did a bunch of stuff like that. I was always riding a bike. It was like my freedom as a kid, but my next question was, well, what are all the parts in the wheel called? I really didn't know, so
Yeah.
I've literally started from the beginning, and then we just got, I've always done all the design work, me personally, in house, did all the did all that, and I've just learned a ton over the years. It's been a lot of fun.
That's intense. I mean,
Yep.
just the whole learning of a wheel and even like the industry that you're kind of like going into. I
Yeah.
mean, man, that's pretty sweet. And so, and I mean, I don't know if you guys were really the first ones, but I mean, you're the ones that came into this market and said, wheels do not need to cost 2 grand. They don't need to cost $15 a piece. We don't need to sell them to a bike shop. We can sell them directly to you. And
Yeah.
again, like I think that was like a really, I mean, it's like on the swimming side, that's like what Roca did, right? Roca said we don't need to sell to shops, like we can sell to people. And you guys did it
Yeah.
in the same sense too, and it just kept things rolling. And I mean, I don't know what the recent wheel count was at Kona. I don't know the last time. Oh, 2018. No, 19 is when Kona happened.
Yeah.
But I mean, you guys were crushing it with
Yeah.
just wheels at the highest level.
Yeah. No, we've been fortunate. I think I won't take the claim as the first consumer direct wheel. I won't do that. But what we did that was unique was we were the first engineered consumer direct wheel. And so to me, there were two types of companies when we started, and there was companies that were highly engineered, like a company like Zip. Great wheels. I still think they're great wheels. Um, they had great engineering, and they went through standard retail, so they were expensive, 2,800 at the time. I think now most of their wheels are in the $4,000 range. And then there were guys that were bringing them over consumer direct. But basically, what they do is they just go over to a factory. They find a model that a factory makes, called an open mold. Anyone buy them? They put their sticker on it, and they sold it. Most of those companies have now closed. But what was, I guess, bad about that, it was a great business model to some extent from a supply perspective, but on the design side, there was really no engineering behind it. Nothing was designed. There was no wind tunnel testing. There was no, I mean, some guys would put stuff in a wind tunnel, but that's not designing something aerodynamically. It's just, well, I can take any shape and put it in and say, what does it do aerodynamically? But you're not looking at it from how do we make something a fast perspective. So that's what we did, is we merged those two worlds. We say, hey, we have engineering backgrounds. We're going to design everything on our own. We're going to use computers to do that so that it's more affordable. And then we're going to sell it consumer direct. So we're going to cut out all that middleman cost. And so we're the first, and to my knowledge, only company that's done that in the wheel space. So that's
Cool.
our claim to fame.
Yeah. So, I mean, this is going to sound like either, for some people it might feel very basic, but I think I really want to get into the basics of, when you look at aerodynamics on a wheel, I really want to get into or have you explain, drag, what is drag, yaw angles, how that affects wheels. So, I mean, can we kind of run through that,
Yeah.
like the basics of that, so people who may not know have an understanding of what comes into play here.
Yeah, I mean, these are great questions because the basics. There's so many myths in cycling. Like, there's just so many, and they're just like these old wives' tales that continue and they go on, right? So aerodynamics, and I've always explained it this way. Most people think about weight and they're super concerned about weight. And I think when people talk about aerodynamics, they're like, well, that only matters if you're going 20 miles an hour plus, which is just complete nonsense. It matters everywhere. The truth is the slower you go, the more time you save on a course, than because you're experiencing the time savings longer. Those are just some of the quick myths. And my theory has always kind of been, anybody can measure something from a weight perspective. So you and your buddy can get together and say, hey, look, how much does yours weigh? Mine weighs less, so mine must be faster. But you can't do that aerodynamically. Two guys can't show up that are just hobbyists and say, here's my bike, here's mine. Mine's faster aerodynamically. I mean, you have to go to a wind tunnel, which is like $600 to $800 an hour or whatever you're spending for that. You can do some on-road testing, but it's extremely complicated. So it just kind of gets blown out, and the people make up these theories, right? So and they just don't generally hold. So drag and aerodynamics are like on a scale it's like 50 to 1, so it's 50 times more important than weight in most situations. There's different situations in cycling, like you can get it yourself in different environments, but if you're thinking about weight, that's why I said totally like overrated in your question, right? I mean, aerodynamics and that sort of stuff and any type of energy conservation is what you want. So I mean, ultimately anything you're doing on a bike perspective, if you're thinking of rolling resistance or aerodynamics or anything that you do, is the reason you think about that and the reason you're concerned about that is because you as an engine, you're putting out a certain number of watts, right? And you want, if you could, ideally you would be 100% efficient. So you put 250 watts out, well, 250 watts is moving you forward. But all these things get in the way. So aerodynamics is one of those, and that's drag. So basically, anytime you're producing drag, some of those 250 watts are being consumed, they're being absorbed. So the lower I can make that number, i.e., the more aerodynamic I can become, the more efficient I get. So a simple way to understand drag and water is a lot easier to, they're both fluids. Air is a fluid, water is a fluid. They're just different densities, and one's a gas and one's a liquid, but visually and how you feel it is a lot easier. If you think about taking your hand and like putting it in like a bathtub or like a lake or whatever, if you take your hand and you move it this way through the water, there's a very strong force. Like if you're taking a swimming stroke, if you were to take your hand and you turn it to the side and you move it this way through the water, it chops through very easily. So that this shape is more in water is called hydrodynamic, not aerodynamic, but it has less drag. It moves through the air easier. So your muscles don't work as hard. It's more efficient. This way, there's a higher drag force in the water or in the air. So as a cyclist, as your body or any of the gear that's on your bike, what you want to do is you want to make it more like the knife blade of the hand. You want to move through the air easier because those watts are not being they're being preserved, right? So you're actually taking them from your body and making them move you forward as opposed to being absorbed by something like drag.
Yeah.
Does that make sense?
Yeah, and it's
Yeah.
interesting, on that. I mean, and if you go back and you look 20 years ago to 10 years ago, in terms of even just like just say like one's body on a bike, and you think of how people were riding on bikes 20 years
Yeah.
ago and their body shape to now, it's amazing when you think about like that knife aspect of just like getting through that quicker. And
Yep.
you made one point too that was interesting, like a little bit of a myth on aerodynamics for slower people. It just doesn't matter. Like just the slower you go, it doesn't matter. Or it's like that. It's like you can only use a disc wheel if you're going 25 miles an hour. Anything slower than
Totally
that,
nonsense.
it's like, well, where did that come from? It's like,
I don't, it doesn't even make any sense. And here's the thing that frustrates me the most is people think of it from a ground speed. It has nothing to do with ground speed, right? I could be on the ground and I'm going 25 miles an hour and I have a tailwind, and that's 25 miles an hour. Essentially, there's no air moving around me. I'm in a still zone. So the disc or whatever equipment I'm using is doing nothing, right? It's your relative velocity. So whatever the wind speed is hitting you at, so you're going ahead 10 miles an hour and there's a 20-mile-an-hour headwind, you hit 30 miles an hour, right? So it's one of those huge myths. Don't listen to
yeah,
that. Always have aero products. I don't care what speed you're
always.
going.
It's like,
Always.
why wouldn't you?
Why? Yeah, you're saving.
So I think, when you're looking at in terms of how wheels affect or how wheels increase aerodynamics. So why would I go from a factory wheel that's, there's no additional aerodynamics to that wheel to something that has 30 mils of a depth, 40 mils, 50, 80. So like how does the wheel, specifically the wheel, how does that come into play with reducing drag on one's bike or increasing aerodynamics?
So basically, when you design a wheel, ultimately what you're trying to do is you're trying to create. If anyone's ever sailed, I sail on the side. I love sailing. Basically, it's a balance of vector forces, right? So if you're sailing, if you've ever sailed, you can sail into the wind, right? It's called, you're tacking upwind, or is how you move upwind. And a cycling wheel is a lot like an airplane wing, right? So when you fly, essentially there's a force underneath that's greater. It's called a lift force, and it makes the plane go up. A cycling wheel is the same thing, but it's on its side, so it's called side force, right? So when I have a side force that comes in to the side of the wheel, if I can design a wheel where that side force is strong enough, the vector forces balance out. It's just like a sail; it actually pushes you forward, or it
Mm-hmm.
reduces the amount of drag that you're getting. A lot of people think of a cycling wheel from a perspective of, oh, we're just making it super skinny and narrow and we're trying to, slice through the air. That's not really it. A study that we did in 2015, I built a computer that mounted to the front of a bike, and we collected over 100,000 data points. Those data points that were collected really allowed us to analyze what a cyclist experience is on the road. What yaw angles do they see? And yaw angles, one of the things you wanted me to explain, is basically if I'm going in and the wind is hitting me straight in the face, like directly, and that would be considered a 0-degree yaw. And a
Mm-hmm.
circle has 360 degrees. So if I were to go from 90, the air would come in straight and hit me in like my right ear. That would be a 90-degree yaw angle. So anything less than that is a smaller angle. So 5, 10, 15, 20, all the way over to that 90-degree yaw angle. And then it's just the same on the other side. So it's like negative or plus, whatever that number is. So before our study, a lot of people, there was this assumption that 80% of your time was spent between 10 and 20 degrees of yaw, and the other 20% was spent between 0 and 10. We
Mm-hmm.
completely blew that out of the water. Like, it's actually the opposite. 80% of your time is spent between 0 and 10, and most of that is really consolidated in the first 5. I think 50% is in the first 5 degrees. But there's a very, very, very a small percentage is actually spent at 0. So we're not really slicing through the air. We're using the wheel most of the time as a sail. And if you think about that, that means that there's 2 leading edges. The leading edge is basically what the wind hits first. So it hits the tire. And then because it's hitting the wheel on an angle, let me show you this. I love that you have video. So this is like a rim section, right? So
Mm-hmm.
consider this is the tire. When the wind hits it on an angle, it hits this side, but then on the back side of the wheel, it hits this as well. So there's
Mm-hmm.
like a surface. There's 2 surfaces. And so ultimately, what we're just trying to do is we're trying to balance those forces enough. And when you do that, that's how a wheel becomes aerodynamic. It pushes you forward or reduces the drag because it acts like a sail.
So, I've always heard this, so in terms of like when it's hitting you at those angles, is that, like say if you have, no additional rim depth to again like a 30 or a 40 or whatever, is that the wind will then, instead of moving through the bike, it'll move like with like into it. Is that what you proved incorrect? Is that the wheel, instead of moving through the wheels to create disturbance, it'll actually like redirect it back, with it?
Ultimately, what you're trying to do is most of your, so if you ever look at a yaw versus drag graph, we've got them on our website. There's a number of them, and you'll see this. The way the graph goes is like at 0, you see the drag, it drops. I'm going to go backwards because this is the way the screen shows. But it drops, it gets to a low spot, and then all of a sudden it spikes back up. So that spike is what's called a stall point. It's like a stall point in a wing stall out. Eventually the plane stops flying. And what happens is the air essentially becomes detached. So when you look at a profile of a rim like this, as the
Yep.
air comes around this profile, right, because the wind's
Yep.
coming in this direction, so it builds up really well on this side, but it's basically what we want it to do is we want it to hang on to or stay attached to the backside. If it's
Mm-hmm.
able to stay attached to the backside, it's considered laminar. So laminar flow is good. It's smooth. The air moves in smoothly. Yes, it gets chopped up by spokes, but as it comes off the back half, it can move smoothly into the frame. It can move smoothly into your legs. Eventually, it hits some type of blender on a bike because
Mm-hmm.
everything's spinning and moving. But the longer we can keep it laminar around the side of the wheel, the better we get
Yeah.
aerodynamic performance. When the air becomes detached, right? What happens is it comes off and there's just a ton of turbulence, and that air
Yeah.
gets
Yeah.
choppy. So a standard OE wheel that's shallow, that is like a box rim, essentially has no attachment.
Hmm.
It just explodes the air as soon as it hits it. So it's bad. The different depths, typically deeper is faster, but there's a lot that goes into wheel selection, a lot of it being physical, mental stuff as well.
Mhm.
But ideally, those shapes are designed to maintain that air attachment as much as possible. Most of our wheels, all of them, are attach and reattach quickly, detach and at a later stage, and then they reattach quickly, which is another important factor when you're designing it. But what you're really trying to do is just make sure that you have airflow that's laminar as long as possible. And if you can do that, which we do well, you produce a very fast wheel. The different depths just allow you to actually create more of a sail effect, right?
Yeah.
And that's why one would be faster than the other.
Yeah, so I think like in theory then, like when you say, okay, you go onto the website, you're looking at, what like wheel combination you're looking for, and we're talking about like now we're talking about depth of wheel. Ideally, one would think, okay, well, give me a 60 mil in the front and a disc wheel in the back, and that's gonna be the
Mhm.
fastest wheel for me in theory. But I mean, but like you just said, that in theory is the best wheel because it's gonna, make the wind stick or help, attach it to the wheel. But like how would somebody, in your opinion, um, select the best wheels for that athlete or for a specific course. But let's go about the person first. I mean,
Yeah.
picking up the right wheel set for a specific person.
And I'm not trying to jump out of your order, but I'm going to do it just because it makes sense. The
Yeah.
course, I don't care what the course is, really, unless there's like a very few courses. We collected data on, I think it was 6 different Ironman courses, and then we went everywhere. We went through mountains, we went through packs, we went through woods, we went on like ocean rides. The angles are essentially the same, so
Yeah.
don't really worry about the course.
I
Forget
think the
that.
one thing with that is like when people say, you don't
Disc or
want to
no
use
disc.
a disc or no disc because it's like too heavy. It's like, and people use the wording, well, if it's an uphill course, I'm like, I've never seen a 100% uphill bike course.
Don't
Like
worry
it just
about the.
doesn't exist.
We've
Yeah.
studied that. Don't listen to that. Use the
Yeah.
disc. The
Use the
only reason
disc.
you don't use a disc is if the disc is illegal. If the disc isn't illegal, use the disc. That's my
Yeah.
rule of thumb. So here's your the other half of your question, which I think now that we've said that there's 2 things that you really need to consider. Number one, or multiple, but we'll look at each one of them. Number one is when you're picking a wheel, you have to understand the difference between a front wheel and a rear wheel. A front wheel is in a fork, which means it has a steering axis, which means if the wind hits it and you can get gusts or anything like that, it can twist, right? Now, our wheels are designed with an algorithm that we use to optimize rim shapes. It's a weighted algorithm that looks at a number of things, but the 2 main weighting things that we look at are aerodynamics and then what's something called yaw torque, which basically means how twisty or how much does the wheel spin under wind. So we want to obviously prioritize aerodynamics, but we won't do it at the expense of something that is extremely rough to ride. So there's a
Mhm.
lot of yaw torque because we know that the body itself is the biggest drag component on the bike. And if you're in the aero position, then that's good. If the wheel is so unstable from a wind perspective that you have to come out of the bars because you can't handle it, well, you might as well just not use the wheel anyway. You've blown your benefits out of the off the page, so it doesn't matter. So front wheel selection is the most important for an athlete to select because of that steering axis. The rear wheel is different because it's fixed. It's fixed in the frame. So there's kind of this misconception that I'm not saying disc wheels in like a race like Kona could be very difficult or scary. Yes, that is true. But those are very, very rare circumstances. So generally, we'll talk about the rear because that's easier to figure out. You really want to set what your front wheel is based on a few things. Number one, how do you handle crosswinds? And there's like 3 people. Some of them feel crosswinds and they push harder. Those guys can ride really deep stuff. They don't care.
Mhm.
Some people are sort of in the middle where they're like, hey, I feel them, but they don't really bother me. And some people, the minute they get any type of breeze, any type of crosswind, they like freak out. It's like, oh my gosh, I'm gonna die. I need to come out. So psychologically, when you're in a race, if you're continuing to think about your gear and you're always thinking about it, it causes stress. It
Mhm.
causes your heart rate to go up. It causes anxiety, which increases cortisol, which is not what you want in a race situation, right? So you always need to pick something from a gear perspective that you can be comfortable on and not worry about. Our 2 deepest front wheels are the FLO 64 AS and the FLO 77 AS. on paper, the 77 AS is faster, but over an Ironman, it's probably maybe 10 to 15 seconds faster
Hmm.
if everything else is the same. So we get a lot of benefit, and there's certain situations why you would use one versus the other. But our thing is that those 10 to 15 seconds are a lot more important if you're able to stay on the bars or if you're not able to stay on the bars. So if you're somebody who is on a deeper wheel and you know that you're not necessarily comfortable and you have to come under the bars for any reason, you need to downsize in a wheel because you need to be
Yeah.
comfortable and not thinking about it. When it
Yeah.
comes to
I mean,
weight, yeah, go
I
ahead.
mean, I'll just say on that topic, I 100% agree because I mean, I'm kind of like in that I kind of fit within two. I mean, I a little bit of cross when I'm okay, but I'm a little bit skittish, right? Like I'm definitely aware of that. And
Yeah,
I was I'm always running a disc no matter what. But then my friend was like, "Hey, borrow this, 808 essentially for upcoming race." Threw it on a couple weeks ahead of time. I tried riding it. I just couldn't do it. Like I just could not
yeah,
feel comfortable with it was so twitchy for me. So I put back on basically a 40 mil front wheel and I was like a rock, right?
yep.
Just it was and I was like, this is the fastest wheel for me because this is the one that I can hold at all times, no issues whatsoever. But totally agree. I mean, the deeper the wheel isn't always faster if you can't stay aero with it. So totally agree.
99 out of 100 triathletes can handle a 64 millimeter front wheel and a 77 rear. Staggering is good. It helps stability wise. It helps control the front. There's a lot of science behind that, but we don't need to get into that. If you find, and it really doesn't matter from a weight perspective, I've had women that are 105 pounds on a 90 front and a disc, and they rock it. And I've had men that are 250 pounds on FLO 30s because they hate wind.
Yeah.
So ride what's comfortable to you. You know, it's something that you want to consider. Um, but yeah, the biggest our biggest like quintessential set that we've sold for triathletes is like our it used to be 6090, now it's the 6477. It's just it's kind of a bomb
So
proof wheel set.
So you said that that's the wheel that you all typically sell the most is that you said a 64 and the 70 and 70
Seven.
what in there? Yeah, in the rear.
77 AS.
Yeah.
And there, again, the reason for that is because you've got that staggered set. So it's especially on a tri bike, there's some benefits to a deeper rear wheel. Just the way that the body fits and the way the frames are designed, the way the airflow comes off. You can help pick some things back up, and the way it moves onto the wheel. There's some benefits there. Deeper rear wheels are good. If you're going to get two wheels, obviously it would be those two. If you're going to get three, a disc is always great to add.
Mhm.
There's a company called Wheel Builder. They do add you can add a wheel cover to any of our rim brake wheels. They can't do it for a disc brake wheel. So if you get a disc brake bike, you unfortunately have to buy a disc. But yeah, those from a tri perspective, that would be like my number one. And if you find yourself super sensitive to the wind, you can always downsize to like a 49 on the front, and you can keep the 77 in the rear, or you could drop to a 64 in the rear.
Yeah. So now we're only talking about like one piece of the equation is the wheel itself.
Yep.
Now we haven't even talked about tire wheel integration because like that's the newest thing coming out. And I asked you in the beginning, I think I said overrated, underrated, 110 psi, and you're like definitely overrated. And so can we get into tires because tires with the right wheel make a big difference. So like let's kind of get into like that integration with rolling resistance, tires, wheels, how to select all of that.
Yeah, so that's a great question, and
Big question.
yeah, when we started the business in 2000, I started thinking about 2009. Everything was aerodynamics based. 23 millimeter tires were the first tires we used from a design perspective, and they were like huge at the time. It was like somebody using 23s; these are massive.
Well, I mean,
By
I'll say when I first started, I mean, it was like you ride 19 mil tires, you jack those things up to
yeah,
120 psi, and you do that
yeah,
because it's like, there's no contact with the road, but granted, you're just like going up and down the whole time down the road. But
hmm
that's what it was like when I started, was like 120 psi, 19 mil wheels, you're golden. And now it's like, well, yeah.
I mean, that's just like craziness at this point. It's kind of nuts. So in 2016, right after we finished was funny because I had just I built that computer. We did all that stuff. We optimized everything with this optimization algorithm, which in CFD, which is really cool. Made major improvements aerodynamically. And I remember I was in the wind tunnel. I was talking to my brother, and I was like, "What are we going to do for the next generation? Like, I don't know how to make a better wheel." And like within days, we got a call from a guy named Tom Anholt, who's a
Mm.
brilliant guy in the space. And he's like, "Hey man, can I? I've been doing some rolling resistance testing." He goes, "Can I test?" Because we were doing this big tire study, and he goes, "Can I test all those tires and we could like merge the aerodynamics and the rolling resistance?" And I'm like, "Sure, but I don't understand how that's going to matter." And he sent me the results, and I was like blown away. Like I'm like, we have literally been looking at only half of the equation. Rolling resistance is as important, if not more important, than aerodynamics from on a cycling wheel. And so that just led to the complete next generation. And it's all related to tire pressure, which I'm going to get into, but understanding rolling resistance is important because there most people don't even know what it is versus let alone want to consider it. So there was this movement that people were starting to make like wider internal rims, and people were saying like, wider is faster. And yeah, we could see that wider tires were faster. But one thing that we wanted to prove was, could we make a wheel that also improved rolling resistance? And the theory was that if we could widen the internal rims width, that
Hmm.
we could reduce overall rolling resistance because it would naturally make the tire itself wider, even if it was a wider tire. And so we set out to do that, but we had to. I was trying to find a company, or I had built a computer for the aerodynamic stuff, but this type of computer I was not able to build it. So we found this company out of Calgary called Aerolab. They had a prototype sensor. I contacted them,
Hmm.
and we spent about 18 months with them and guys down at UNLV, some great guys down there who we've had on our podcast a few times. And um, we developed this protocol to basically measure on-road rolling resistance. And it was a crazy process. I mean, I've learned so much just about on-road testing doing that. But we were actually able to prove that a wider internal rim width lowered rolling resistance. So what we did from there is we then increased the internal rim width as much as possible, and then we used larger tires because they also had lower rolling resistance. And then we optimized aerodynamically a rim shape around that wide internal shape and the wide tire.
So when you first started making wheels, what was the rim width in the beginning, and what is it now?
I mean, the internal rim width at the time was, I mean, a lot of them, some of the first wheels that we looked at were like 13 millimeters, like
Mm.
internal. There was just like this old thing called the ETRTO, which is a European Tire and Rim Technical something. I always forget the name, what it is, organization. But they just said it, you use like a 19 mil tire, and this is what it was. And so we went out to our first wheels were like 19.4 millimeters
Mhm.
internal, which was wide. But a lot of the carbon stuff we started working with, because carbon molds were different, were in like 16, 17 range. That's our
Mm.
first generation of carbon. It was like, I think 17, and one was around 18. And so we were able to, on the newest generation of carbon, with some new layup structures and some things like that, we moved out to 21 mils. It's much, much wider. It creates a wider platform. And just by changing the internal structure using a wider tire, which we know aerodynamically a wider tire is slower, but it makes such an improvement rolling resistance wise that it actually is faster than a narrower tire. And because we were able to optimize the rim shape around that wide tire, it just made more and more benefits. And so over our fastest previous generation, which was our second generation, which was already very fast, we're saving like over 2 watts per set, which
Mm.
is huge when you think about it from an output perspective. So that was a huge thing. Tire pressure really comes into play because rolling resistance is really managed best by tire selection, so wide tires and around a good rim, and tire pressure. So what happens when you have a very, very high tire pressure is the road surface itself, while most people think it's flat, it's not flat. There's all these little bumps. If you get down like a very close, smooth pavement is the best. It's the smoothest, but still there's bumps. And then rougher pavement, obviously there's more bumps. So if your tire pressure is so high, what happens is that wheel goes over that pavement, it
Mm.
starts to bounce and skip. And so as we talked about earlier, you want to conserve that energy as much as possible. As opposed to you moving forward, you're starting to bounce up and down. And so anytime that bike is moving in an up and down motion, then you're wasting energy. the vibration of that also, we're doing a lot of vibration studies right now, which are really cool. But it also goes through your body. So anytime it goes through your body, your muscles basically rub back and forth. It creates fatigue. It creates a lot of things. So there was some work that was done actually by Tom Anhall, again, great guy, and a guy named Josh Portner over at Silka. They were studying some things and they found this thing called an impedance breakpoint, which basically is if you look at pressure and you look at the rolling resistance number, it drops because in a lab on like steel rollers, the highest PSI is the best because it's ultimately super smooth and it just your rolling resistance keeps dropping. But on the road, because of these bumps, eventually your PSI or your rolling resistance drops until a certain point when it just automatically spikes and shoots up. And it's very, very drastic and you lose a lot of time. So what we found was we basically studied ranges with our wheels and tires and different road surfaces that allowed you to avoid that impedance breakpoint. And we have like pressure tables and certain things like that. So if you're below that, you're actually much, much faster. Another thing that we did that we were the first ones to discover because of this on-road protocol is that impedance breakpoint changes with speed. So the faster you go, the sooner it happens. And there's a lot of things that are taken into consideration. But when you want to manage your tire pressure, I would say go out to like our website. Each wheel page has like a rim width range, a tire size, and it will give you a pressure based on your weight. And that's just going to save you a ton of time.
So because you keep using the word, it's either integration or optimization. And so I think, instead of looking at, okay, well, this is like a really fast wheel, but when you're looking at the three things combined with, the wheel, the width of it, and also the tire width, and also tire pressure. I mean, so let's say if you're riding an older wheel, that the rim width is much smaller,
Yep.
and but now like, oh, people are saying, oh, well, we need a wider tire. A wider tire is faster, and you go and throw on like a 28, right, or something like that. Now, is that going to be quicker, or is because it's not really like optimized correctly? Is it really not going to get as many gains that you would think if you have a wider rim width with a wider tire? You know what I'm saying? Like, do you have to have
Yep.
all three set to work perfectly together, or if one thing is off, then it's not as quick as you might think that it might be, or it might be slower?
Great question. Ideally, you want all three managed. So if somebody's designing a wheel, then you're hoping that they're taking all three into consideration. A lot of companies don't, but if they're doing it right, then you've got generally a tire will be recommended for a wheel because it's optimized around it, and there are just better tires. So if people aren't optimizing around the best tires, I don't know what they're doing. So you want to take that into consideration. If you oversize a tire, yes, you're going to lose the aerodynamic effect. You can. It gets too big for it, and so then you start to lose some of that. You're going to gain some rolling resistance, but you're probably going to at some point lose the aerodynamics. But here's what I'll tell you. What I learned we designed a gravel wheel series as well, and we made them aerodynamic, which is kind of complex with think of a gravel tire tread. It's very bumpy, which is not good for airflow being smooth. But in that process, what I learned is if you look at a tire that is, because on the gravel side you can see it. You can see like something up to like a 48 mil tire or even larger, and then down to like a 35, 37.
Mm-hmm.
So we always study on like an OE rim, just like a basic rim, and then we study on ours. So the aerodynamic difference between the base rim, which would be like a Mavic Open Pro, and then our wheel, that change is generally the same, but one tire will be more aerodynamic than another. So the aerodynamics basically, the benefit stays the same, but your overall number is different because one tire is worse or better, right? So when you're looking at it from an oversized tire perspective, yes, you're probably going to lose some aerodynamics, but you really want to consider what is best for that wheel tire combination.
Yeah. And this may sound like an incredibly dumb question, but I'm curious, like, can you look, if you're just like walking around a triathlon and you look at these people's, wheels, with the tires. I mean, is there a look that you can say, well, if this thing just looks like a giant mushroom, this thing's definitely slow. I mean, if it's like it's a good visual, right? But like if it's more like plush, right? Like if it's definitely like a plush kind of look where it all looks pretty integrated, like is that going to be a good indication that you have like a better setup to that?
Uh, I've spent enough time in a wind tunnel to be humbled by a wind tunnel. Um, I've looked at things and thought they're going to be super fast and they're horribly slow, and I've looked at things that thought they're going to be terrible and they're super fast. So I don't know.
Yeah,
I
yeah.
would like to say that my trained eye at some point could look at something and say, you probably get a pretty good chance. Maybe, but I could be missing something as well. Obviously, testing is the best. It's why we do a lot of testing, because we want people to rest assured and say, like, I know this works because they've tested it and they've designed around it and it's been proven. I think that's important. There are a few things that you can definitely avoid. There's a rule of Josh Porter came up with this thing called the rule of 105, which again, I'm not knocking on anything he's saying, but there are certain things nowadays with wider things and some of our optimization algorithms. And when you're taking rolling resistance into consideration, that's we don't necessarily see the rule of 105 always being the fastest. It's really case by case specific. So I'm not saying it's bad. I'm just saying that's why people look at it, they measure something, and say, "Oh, this must be fast because of this rule of 105." You really don't know until you test, and that's
Mhm.
kind of the rule. So just if you have a good company that does the testing, just trust them and go with it.
So, I want to ask a question again. Like you hear again, this is like one of those like don't use a disc wheel, use a disc wheel kind of a question. But when we kind of just like get into tire pressure, and this is something also like that we're kind of we're hearing more about where so people say, well, I don't want to run lower tire pressure because I don't want to get a flat tire. Now, I mean, let's say if you're 150 pounds or 120 pounds and you're kind of riding through, I mean, when I went through the Silka tire pressure website, for tire pressure, with my combination running, I mean, he recommended I'm running, I think roughly around 70 PSI. I'm
Yeah.
155 pounds and I think if I were to hear that 10 years ago, I'm thinking there's no way I'm gonna get a flat tire within 10 minutes. But can
Yeah.
we like what is the likelihood like and also this can also segment into tubeless for
Yep.
this kind of a situation. So but like yeah, let's talk about tire pressure.
So there's a couple things you really need to think about. Number one is there's a human element of this, that there's a perception thing that happens. So there's a study that was done in Germany, and it was done in a car, and they were trying to test for the fastest, or the what people perceived. It was a perception test, and so they put people out on a car, they blindfolded them, and they said, "We're going to run you down 3 roads, and we want you to tell you which one is the roughest," right? And they ran them down the same road all 3 times, but they changed the speed:
Mm,
70 kilometers an hour, 80 kilometers an hour, and 90 kilometers an hour. And everyone said that the faster the car went, the rougher the road got. The reason for that is because as you go faster, you get more vibration. And vibration, as a human, feels rougher, but you also perceive it as faster. It feels faster. So the most difficult thing to overcome with tire pressure around the flat issue is that when somebody goes out and they pump up to 120 and they go for a ride, they get that buzz that comes from
mm,
the road and it feels fast. The minute you take them down to 70, it's very smooth. And so people are like, I'm slower. I just know I'm slower. It feels so much slower. But
mm,
if you monitor it with power and you look at it, they're always faster.
mm.
The other thing is, we just studied with Union University where we actually mounted strain gauges inside of tires, and there's a thing called casing tension. Casing tension is basically when you inflate something like a tire, it's pneumatics, but there's a tension that happens inside the casing that's holding that together. If you look at like a fat bike, some of the PSIs on fat bikes are like 2, 3,
Yeah,
right? But if you
yeah.
touch a fat tire, it's very hard. If
Hmm.
you were to do that on a road bike at 2 psi, you don't even know you have air in there,
Yeah.
right? So that casing tension, the bigger the tire gets, the lower the PSI has to be in order to have that same casing tension. So 70 at whatever your tire size is definitely safe. If you're riding so low that you're getting flats, you're too low, right? But if you're optimizing it, if you're getting a flat at 65, it doesn't mean you'll get one at 75. You don't have to go to 120. Find that happy medium is really what you need to do.
Yeah. And so I think one of the last questions really, I mean, is now we're looking at tubeless. Tubeless
Yeah.
is now coming into the equation, and I guess the biggest thing is if you're optimized with everything, is a tubeless tire going to be faster than a tire with a tube in there? Big question.
Yeah. If everything else is the same, yes. But tubeless tire construction is different than non-tubed construction. So generally, sort of the rule of thumb is that if you're using a latex tube or tubeless, they're kind of the same. Somebody can probably crucify me over that or come up with a reason why that's wrong. And I can probably come up with the reason why it's right. I just think that tubeless I love tubeless at this point. I don't, unless you don't ride enough where it dries out, then it's a complete pain. If you ride enough, tubeless to me is becoming an absolute no-brainer. And the tires that are being developed today are just that good. Like the new Continental 5000 RS or SR, I always forget the name of it. But it's the newest one or TRS or something like that they just came out with. Use that all day, run it tubeless, and don't ask any more questions. Just do it. It's a great tire.
Sweet. All right. Well, I mean, before we kind of close it up, I mean, is there anything that we think we may have missed that they may want to bring up?
I just wrote a blog article, and so it's on my mind, and I think it's important, so I'll say it. When you think about tires, a lot of people will look at a tire and they'll read a review on a tire. There's some tires out there that have incredibly low rolling resistance, and they're like, "Oh, this is the fastest tire in the world. I'm going to use it." Or they'll read something about something that's very aerodynamic. "Oh, this is great." Or they're worried about the durability of the tire, so they go to the extreme case of a gator skin. So that's why I said the overrated, underrated. Gator skins are incredible aerodynamically. They blew me away when I looked at them, but they're like rolling resistance. They're tanks. They're horrible. So what you need to think about when you select a tire is they're like a three-legged stool. And I always say this: you have rolling resistance, aerodynamics, and durability. And if you lose any one of those legs, the stool falls over. Your tire essentially falls over. There's a Vittoria tire. It's incredibly great rolling resistance wise. In the wind tunnel, it's not good. And durability, it's like rice paper. So they did a great job rolling resistance wise, but it doesn't make sense overall. The best tire that we've ever found, that we've ever used, and it's been multiple generations of from a durability, rolling resistance, and aerodynamic perspective, is the Continental GP 5000. So use them. And I don't care what wheels you have, just use them. Get those tires. They're great tires.
Cool. Well, again, I mean, I think when we laid this out, we had 2 sections and we filled almost an hour of this with a lot of like really good practical info that I hope that everybody, takes out of. And again, it's been awesome to talk to you, and I can't thank you enough.
Thanks for having me on, man. Look forward to talking to you in the future.
Cool.